Hello everyone. I am Dr. Renjith Bhaskaran, currently working as an assistant professor in Department of Chemistry at Madanapalle Institute of Technology and Science. First, I will give you a brief summary about my academic profile. I completed my BSc in Chemistry from Union Christian College, Alava in Kerala. Completed my MSc from Mahatma Gandhi University, Kottayam. Then, after clearing GATE, I moved to IIT Guwahati for pursuing my PhD, where I specialized in theoretical chemistry. Subsequently, I moved to IIC Bangalore as a research associate under the guidance of Professor K.L. Sebastian at IPC department. Then in 2016 January, I moved to Texas A&M University for pursuing my postdoctoral research work. In 2017, I came back and joined in this institute as an assistant professor. Also, currently, I am heading the Department of Chemistry. Now, in today's lecture, I would like to give a brief introduction about the basics of titration. So let's start with the topic. Basics of titration. So before moving into the details of this condense, let me give a very clarity in the first sentence itself that this lecture is mainly intended to address the concepts for intermediate level students. That means those who are pursuing their studies in the 11th or 12th standard, or even those who have just entered into the undergraduate first year courses. So, when we talk about titration, uh, mostly you might have heard about it. This is an experimental technique that we used to perform in the laboratory. But quite often time when I discuss with the students, they may not have that much clear-cut idea about what is titration, why we need to do these things, etc. So in this first lecture, my main aim is to give you a very basic idea, a very brief idea about what is titration, how can we perform titration accurately, and how we'll be able to analyze the results. So let us begin with basically titrations are of many types, but in this today's lecture, I will be mostly focusing on acid-base titration. Acid-base titration. So when one have to think about doing a titration, imagine you are in a situation where you got a solution, and I hope that all of you know about what you mean by a solution. So you come across a situation where you got some solution in a round block bottom flask or in a SMF or maybe in a beaker. And say, for example, I am going to give you a solution where I'm going to tell you that this is a HCl solution, but I'm not going to talk about its concentration. So I have no idea about what is the concentration of this solution. Now I am asking you, can you find out the concentration of this solution? So your answer should be yes, I can. But how do I find out? I can find out the concentration of this HCl solution by performing a simple acid base titration. So for finding out the concentration of this acid, what are the other chemicals that I require? So you require a base solution whose concentration must be known to you. So for example, I am going to give you a base solution that is a NaOH solution, for example, and I am telling you the NaOH solution is of 0.01 normal concentration. Now, why did I choose base NaOH? This is because and you should always consider the solution which can react with the analyte that I have given to you. So in this example, I have given you HCl as the analyte, where you need to find out the concentration. So your reagent is HCl, and this HCl should react with the, your analyte is the HCl, and you should always take the reagent such that it should react with your analyte. So we know that acid can always react with the base. So that is the reason why we have chosen NaOH base. You can choose other bases as well, but since HCl is a strong acid, we have taken NaOH as the strong base. Now, when an acid reacts with a base, what are the products that you are going to get? So this, I'm sure you might have studied in your intermediate level, that when an acid reacts with a base, you are going to get the corresponding salt and water. So in this example, when HCl reacts with the NaOH, the base, you are going to get NaCl as the salt and water as the byproduct. So this type of reactions are known as neutralization reactions. So when you do an acid-base titration, what is the reaction that is taking place? Which is neutralization reaction. Now, this is the basic principle of acid-base titration, that when an acid reacts with a base, you will get the salt and water. Now, how can we perform this titration in laboratory? So basically, why we need to do titration before doing that? What is titration? Titration is an analytical technique that we used to do in our laboratory for finding out the concentration of the given analyte sample. Once again, titration is an analytical technique that we use to perform in our laboratory for finding out the concentration of the given analyte sample. So in this example, we have taken HCl as the analyte solution, where I do not know about the concentration of the given solution. So how I am going to find out? I am going to do a titration of the given analyte with a reagent which can react with the analyte, that is NaOH solution. So for you can ask me this question. So if I want to do a titration, these two chemicals are sufficient? Normally the answer is no. These two chemicals are not sufficient. We need one more chemical in this case, and that chemical is called indicator. Indicator. So what is indicator? Indicator is usually an organic dye, that means the coloring compound, maybe phenolphthalein or methyl orange, which can change the color during the course of the titration. So how do they change the color? That I will discuss in my next lecture video, next lecture. But for the time being, let me tell you, this is a compound which can change the color when there is a change in the pH. So during the titration, you should understand that there will be obviously a change in pH. And when the pH change abruptly, the indicator will indicate a color change. So in this example, let me choose phenolphthalein as the indicator. Phenolphthalein. So remember one thing, phenolphthalein is colorless when the pH is less than 7. That means in the acidic medium, that is the most prompt way of or accurate way of addressing the color change. And it is pink in color, when the pH is somewhere between 8 to 10. So when we want to do a titration, we need indicator also. Now, in some other cases, say for example, if you want to do a complexometric titration, you need to go for adding buffer solutions also. So, but I am not going to discuss about that here. I will stick to the acid-base titration only. So, for doing this acid-base titration, we just need this indicator as the extra chemical, nothing else. Now, how we are going to perform this titration? So for doing the titration, when you go to the laboratory, you need to have certain glasswares or apparatus. So the basic apparatus that we require is, first one, we require a burette. So I'm just trying to draw a burette over here, burette. And I hope you might have seen the burette in the laboratory. Maybe it's not clear cut for you, but sorry for the inaccurate representation maybe, but I try to draw it at my level best. So burette is like the long tube, glassware which you can see in the laboratory. Always you will keep it in a burette stand. Now, in addition to this, you should also require a pipette. Pipette will be again something like this. Um, so something like this, and here again, I hope it's not really good, but again, I hope you can understand that. And the normal capacity of the pipette will be 20 ml. But it doesn't mean that like you can always use 20 ml. You can use pipette 10 ml also. Whatever may be the quantity of the pipette you have, you can just go ahead with that. Standard pipette what we used in our laboratories of 20 ml. And the capacity of the burette is, by the way, 50 ml, which I forgot to mention, but I hope you all might be knowing about it. So then, in addition to that, when performing the titration, you also require another apparatus, that is the conical flask. So I am just going to draw a conical flask over here. So is it sufficient? Yeah. For the time being, for doing the titration, these three apparatus are minimal requirements I am talking about. This is sufficient. So how do we use them? And which chemical we will be taking in which apparatus? This is the thing I am going to do next. So I am going to say about next. So we have given you, so in the previous slide, if you look into, I have told you I have given you the analyte sample, which is the HCl solution, which is given in an SMF. So this solution you have to prepare. So the SMF solution, once again, I will draw here. That is the HCl solution. You have to, so you have to, once again, I'll just, mm, okay, I hope now it is much more clearer to you. So the HCl solution, whatever we have given here is little bit only, this much only, where you want to find out the concentration. Now what you need to do is you have to add distilled water to this SMF and you have to make this solution up to the mark. So in all the SMF means the standard measuring flask, there will be a mark in the long tube, and that mark will be usually represent the maximum capacity that you can prepare. So, for example, I have given you 100 ml of SMF, 100 ml of SMF. So you can add distilled water and you can make the solution up to the mark. And you have to mix the solutions by inverting the SMF up and down several times so that you can make the solution homogeneous. So after making the uniform concentration solution, what you can do is you can take the pipette, use the pipette, and you can pipette out 20 ml into a clean conical flask over here, 20 ml. Because as I said, there is no strict policy that you should always use 20 ml. But usually when we go to the chemistry laboratory, we will be having the standard pipette which is of 20 ml. So 20 ml will be a sufficient volume. This 20 ml pipette, using the 20 ml pipette, you should pipette out 20 ml acid into the clean conical flask. Now, what you need to do next? So I have also given you the Na void solution, which I have shown here, which is maybe I might have given you in a beaker, and that is again a colorless solution. But I have already told you the concentration of the NaOH solution is 0.01 normal. So by using a funnel, you can transfer this base solution into the burette. But since it is a colorless solution, always remember you should fill the burette and add the solution up to the mark, but by keeping the lower meniscus. The lower meniscus should touch the zero. And okay, again, while filling the burette, there should not be any air bubble at the bottom of the burette. And you should also avoid a parallax error by keeping while measuring the lower meniscus, it should always keep straight line with your eyes. So the NaOH solution you have taken in the burette, 0.01 normal NaOH solution. Now, you have one chemical left over there, that is the indicator, phenolphthalein. So what you want to do here is, now where will you keep this? So you have taken the acid solution in the conical flask, Now to this solution, you have to add 2 drops of the indicator, phenolphthalein, just 2 drops. Now when you add the indicator, you are adding the indicator into an acid solution where the pH is always less than 7, so it will be a colorless solution. This is a colorless solution. And remember, we have not started the titration yet. This is just a setup for doing the titration. So the titration will begin once we are ready with all these things. So once again, how to perform this acid-base titration? First, we need to make the analyte solution, that is the HCl solution in this case, by adding distilled water and make the solution up to the mark. Then pipette out 20 ml into a clean conical flask. Then add 2 drops of the indicator phenolphthalein. Then fill the burette with the given NaOH solution. So here I can call the NaOH solution as the standard solution because I know the concentration of the solution. And the unknown solution is, of course, the HCl solution. And what is unknown there? The concentration is unknown there, which I want to find out. And titration is a technique used for finding the concentration of the analyte solution. Remember that always. Now, how to perform this titration? So, performing the titration is very easy. You just release the base solution from the burette dropwise. So dropwise means you just open, there is a knob here. This is the knob which I am talking about. It's like a tap. So you just open the knob using your left 3 fingers. So titration. So conical flask should be handled by the 3 fingers from the right hand, and the knob should be handled, the burette knob should be handled by the 3 fingers from the left hand. So you just open the burette and then slowly add the base solution from the burette dropwise. And when you slowly add this base to the conical flask, there is a reaction that is going to take place, and that reaction is the neutralization reaction, which is I have already shown in my previous slide. You can see now on the screen, the acid react with the base, and which will give you the salt and the water. Now, we do not know how many acid is present in the conical flask because we just pipetted out 20 ml. So we do not know how many H plus ions are present over there. Now, when you keep on adding this base from the burette, this acid is obviously going to react with the base. But then we do not know how much base is required for the complete neutralization reaction. So how do we come to know that? So this we will come to know that with the help of the indicator we have added in the conical flask. So when the complete H plus ions, say for example, I just assume that there are 10 H plus ions which are present in the conical flask. So if there are 10 H plus ions, I require 10 OH minus ions from the burette to react because this is a 1:1 1:1 ratio reaction. So if the the HCl and NaOH solution. So when 10 H plus ions are there, obviously you require 10 OH minus ions. So when they react, you will get 10 water molecule. So, but my problem is that I don't know how many H plus ions are present, which is unknown. That's what I am going to find out. So the thing is that since I am not aware of this one, how do I come to know that how many OH minus ions are required? So that idea you can gain from the help of indicator, that the indicator will change the color. Indicator will change the color when the reaction completes. So when the reaction completes, what happens is the phenolphthalein, which was colorless in the acidic medium. So when the reaction just over, and when you again started adding NaOH from the burette, the color will immediately changes to pink. So what is the color change? From colorless to pink. So when you observe the pink color, you should stop adding the burette solution, and that point is known as stopping point of titration, or to be more precise, end point of the titration. End point. So your titration is over, and then you should note down the burette value. So how much volume of base you have released from the burette. So that volume will tell you about an approximate idea about like how much H plus ions are present in uh, the given the pipetted out 20 ml acid solution. So that's all about titration, like how do we perform. So once again, I hope you are following what I'm saying. So the idea here is we want to find out the concentration of the given acid solution. That is, I'm going to call it as the analyte, where I do not know about the concentration of the acid solution. So how I am going to find out? I'm going to find out by performing a titration, and this titration is known as acid-base titration. Now, why did I choose base? Because acid can definitely react with the base, and that reaction is known as neutralization reaction. So when an acid reacts with a base, it will give you the corresponding salt and the water. Now, here I am going to give you Na void solution, that is the base solution, and whose concentration is 0.01 normal solution. So since you know the concentration, I am going to call it as a standard solution. Now, for performing the titration, do you just require these two chemicals? Definitely not. You require one more chemicals, in this case at least. So that is the indicator. Indicator is usually a compound which can change the color when there is a pH change, generally speaking, especially in case of acid-base titration. So in this case, we are going to use phenolphthalein as the indicator. And this indicator is colorless when it is in acidic medium, and it changes the color to pink when the pH changes to somewhere between 8 to 10 or above 8. Now, how do we perform this titration? So, titration can be carried out with the help of minimal three equipments or glasswares, to be more precise. We need a burette, also need a conical flask, we need a pipette. And of course, the analyte I have given you in an SMF, standard measuring flask, and the base also given you in a beaker. Now you fill the burette with the given NaOH solution with the help of a funnel. And remember, while filling, burette should be, there should not be any air bubble. It should be the lower part of the burette should be completely filled. And you should always fill the burette up to the 0 mark, keeping in mind that since this is a colorless solution, lower meniscus should touch 0. And in the SMF, you have the HCl solution, which is the analyte solution. And you have to make up the solution by adding distilled water. And you prepare the solution up to the 100 ml. Then pipette out 20 ml of the analyte solution into a clean conical flask. Then add 2 drops of the indicator. And when you add the indicator, you won't see any color, which is completely colorless because you have added into an acidic pH. Now, when you start doing the titration, you are going to slowly add the base from the burette. So, during that time, some reaction is going to take place in the conical flask, which is the neutralization reaction. And when the complete reaction is over, indicator will indicate that, okay, your complete reaction is completed. Now you stop adding the burette solution. So, how do they work this one? How do they indicate? This will be indicated by there is a color change. And the color change we are going to see is the formation of a pink color. And when it forms the pink color, you should stop adding the burette solution. And that point we will call it as either stopping point, or to be more accurate, we will call it as an end point. Now, once you find out the end point, you should note down the burette value. And this value we are going to tabulate in a tabular column. So you need to draw a tabular column here. I'm just going to draw a simple uh, titration. So here the first column is for noting down the serial number maybe. And the next column is for the volume of NaOH. Oh, sorry, it's not the NaOH, it is the acid. So uh, just a moment, I made a mistake here. Yeah. So volume of acid solution taken. And in the next column, we are going to note down the burette reading. So in the burette reading, again, we have two reading. I'm sorry. So there is again two readings will be there. One is the initial reading, okay, then final reading, and the last column is for concordant value. So all this tabular column is completely used for noting down the volumes. So we need to do this titration minimum 3 times, because when you do the titration first time, you do not know, you don't have any idea about how much volume is required. So we chemists usually call it as the rough titration. So let's say, for example, first time when I am performing the titration, I have pipetted out 20 ml of the 20 ml of the acid solution. And my burette reading, initially the burette was in 0, the lower meniscus. And when I completed the titration, what happens is the lower meniscus may touch somewhere between 17 ml, 17.2 ml, maybe 17.2 ml. And now what I am going to do, I am going to repeat this titration, because I want to verify that whatever I did is correct or not. So what I am going to do, I will just perform the titration again by throwing all the conical flask solution into sink. Again, I will clean it. I will fill the burette again with the base. Again, what I am going to do, I will pipette out 20 ml of the fresh acid solution from the, not fresh acid solution, already you have prepared. So you will pipette out the acid solution, whatever remaining in the SMF, 20 ml, you will pipette out into the conical flask. Again, you will add 2 drops of the indicator. You will perform the titration again. So remember, you have to fill the burette again. So when you do that second time, carefully if you do, again you are pipetting out 20 ml of the acid, you are burette reading initially it is 0. Usually you will get a value lower than this, because this time you will be very careful. So you know approximately at what volume the reaction is going to complete, and the indicator will change the color. So let's say you are going to get the value somewhere in 16.9 ml. Now, when I do third time, one more time, I would like to verify whether I am doing correct or not, or whatever I am doing is reproducible or not. So when I do the third time, I am supposed to get the same value which I got in the previous titration, 16.9. So whenever I am going to get the adjacent two values as same, I am going to take it as my final value, and I am going to call it as the concordant value. I'm sorry. Uh, Again, eraser. So concordant value. So 16.9 ml is the concordant value. And remember, this is the volume of the base that I have used, 16.9 ml. So now again, when I come back to the titration part, what I will do with these values? So still my objective is left as such. I did not find the concentration of the given unknown solution. So how do I find out that? I have performed the experiment. I have tabulated all my observations. So my observation, the tabular column is ready. It is already filled with the data. Now what I am going to do with this data? So that is very simple. Like there is a normality equation that we used to do for doing the titration. So since we want to know the concentration, and the concentration is usually expressed in many ways, like normality, molarity, etc. So, but for this lecture, I would be stick to the normality. So we will be using a normality equation, which is the very fundamental in the titration experiment. And the formula is V1N1 equal to V2N2. And here, what does the letter V stands for? V stands for the volume of the chemical used for titration. Volume of chemical used for titration. And the N stands for the normality of the solution. But then again, question, you have two different types of solutions. One is acid, one is base. So which one I will take? So to have clarity over there, we have taken maybe we have two subscripts, 1 and 2. If you look at the equation, there is something called a V1 N1 equal to V2 N2. So here, for the sake of simplicity, let me call my first solution as first solution is the burette solution. And my second solution is the analyte solution. So that means the first solution is the Burette solution. That means the standard solution, the NaOH solution. And my second solution is the acid solution. So now I want to know about the values of these V1, N1, V2, N2. Then I will look for, can I find out the concentration of the given acid from this form, from this equation or not? So we will just look into that. So what is V1? V1 is the volume of Burette solution used for titration. So Burette solution is NaOH, and the volume of the Burette solution we have used is 16.9 ml. So when I substitute the value 16.9 for V1, and what is N1? That is the normality of the Burette solution. So that is 0.01, 0.01 equals. Then V2, volume of the analyte solution used for titration, that is 20 ml. We have pipetted out 20 ml each time. And then what is N2? Normality of the analyte solution, which I do not know. That was my objective. So my objective was to find out the normality of the analyte solution N2. So I want to find out N2 now. I can easily find out N2. So my N2 is 16.9 into, sorry, 0.01. Just a minute. I made a mistake over there again. Sorry about that. Okay. So now 0.01 and divided by 20. So when you do this calculation, definitely you are going to get an answer. Maybe I'll tell 8.45 into 10 to the power of minus 3. I am sorry, I did not calculate using the calculator, but just from my mind calculation, I have given this value, but you can verify this value. So this is the normality of the given acid solution in the SMF. This is how we are finding out the concentration of the analyte solution or the unknown solution with the help of titration in laboratories. So that's all from my side in this lecture. I hope you understood the concepts. But in case if you did not understand any of the concepts, whatever I taught, or do you need any clarification more, or if you have any comments how to improve the lecture, or if you have any suggestions to give, you are always welcome, and you can post all your comments, queries, everything in the comment box. And if you wish to listen to any other topics, maybe the basics level or advanced level, that also you can mention in the comment box. And that's all from my side in this lecture. Thank you for watching. Have a nice day. Bye bye.